Let us now talk about deterministic functions. Deterministic is a keyword you can specify while creating functions, which is an optimization hint. This helps the compiler not to execute a function multiple times and use the results from the last execution with the same input parameters. This, however, is only possible if the function solely deals with the input parameters inside it and always returns the same return value for the same input values. So inside the function, it does not alter or access any package level variables or database tables. It only does, say, some computations or logic processing based on the input parameters to return the result. For instance, the upper function we talked about earlier takes in a character string and returns the uppercase representation of it. So if the input value is the same, it will always return the same output value. What if a function is not truly deterministic? Say it alters the data in some tables or package variables, but you have marked it as deterministic. In that case, if the compiler chooses not to execute that function again for the same input value, it might lead to incorrect results. So you have to take care that if you are marking a function to be deterministic, then it truly is, and it is not modifying any package or database state in any way. This restriction is in place for any other subprograms which might be called from inside the function. Only deterministic functions can be used with function-based indexes and materialized views. We haven't talked about function-based indexes. We will talk about it in a later course, but what it is that if you put a function on a column in the where clause, then Oracle will ignore any indexes on that column and will do a full table scan where it could have done an index scan otherwise, thus reducing performance. Function-based indexes helps you create an index on that function, thus allowing Oracle to use an index scan versus a full table scan. Materialized views allows you to run complex queries and aggregations, pre-compute and store results for very fast response times. You can only declare a function defined at a schema level, or declared in a package specification, or in a type specification as deterministic. We haven't spoken about types as it is an advanced topic, but just wanted to mention it here for completeness. You cannot declare functions local to a procedure or function or anonymous block, or local to a package body as deterministic. In order to understand the performance gain using deterministic keyword, first let us take a look at a function defined without using it. So here is a regular function getTier which takes in psal number parameter and returns the tier in which the salary falls. Inside it compares if psal is less than 40,000, then assigns lreturn as 1. If psal is less than 60,000, then lreturn is 2, otherwise lreturn is 3. We print psal input parameter and return lreturn. Now in this code snippet, we select empid, empsal, and getTier, passing in empsal as parameter from employee table, ordering it by empsal. This is what we get back. So we have 2 employees with a salary of 40,000 for which it calculated a tier of 2, and 2 employees with a salary of 70,000 for which it calculated a tier of 3. Also, if you run it as a script in SQL Developer, we would notice the DBMS output statements from the function. We see 4 of these, 2 for 40,000 and 2 of them for the 270,000 rows. So the function got executed for each row. However, this function is a perfect candidate for being a deterministic function as it only deals with the input parameters, does not modify any package or database state, and would return the same output based on the input value. Let us see how we can make it deterministic. Here is the same function. The only difference is the deterministic keyword we have added after the return and before the as keyword to make it deterministic. Now when we run our SQL, we get the same result, but this time when we observe the DBMS output statement in the console, we notice that it ran the function just twice, once for each unique input parameter value 40,000 and 70,000. For the second run for each of these values, it did not re-execute the function but used the computed value from the last time. So if this function was operating over say hundreds or thousands of employee records, you can imagine the amount of cost savings of resources and performance gains which you will get all by specifying an extra word in the function declaration.